So, important pieces of information. Why can't I reach this? X number of field goals worth 2 points each. Okay, what else? What else is important? Brandon.
He scored 20 points.
One other important piece of information. Brandon. He's looking. Come on. Yeah, but what's an important piece of information besides he scored X number of field goals worth 2 points each? 100 points. Yeah, that's important. Anything else? Right, 28 points. Now, that 100 points, that's his total, right? When you have an equation, where do you usually put the total? At the end. So let's put this total at the end. And you know what? I almost think we shouldn't write it like this. We shouldn't give you that. I think that's too much help. So this is total points. Okay? Total points. Now, his points are made up of two different kinds of baskets. All right? One type is what? He's shooting. He got 28. Those are free throws. Okay? How many points did he get out of the free throws? Free throw points. How many? 28. It tells you that. What are the other kind of points that he got? Field goals. First time I read that, I was like, field goals? Is that what they call them? I guess it is. Field goal points. Okay? So to get my total points, what do I have to do with my free throw points and my field goal points? You have to add them, right? We're going to combine them. Now, how many points did he score in field goal points? No, I want field goal points. And we know there's how many points for every field goal? 2 points for every field goal, right? 2 points for every one field goal. So, if he made 2 field goals, how many points would that be? 2 times 2, which is 4. If he made 7 field goals, how many points would that be? Right, 2 times 7, which is 14. How many field goals did he make? We do, sort of. How many? It said he made X field goals. So, how many points is that? No. 2 times X, which is 2X. So, here is my equation. 28 plus 2X equals 100. And so, which one does that match up with? Letter A. Now, here's my question. Could you have come up with that on your own? No? Okay. But this is how you have to approach it. You have to say, they give me the total number of points. Put that down. You know a total is at the end of the equation, right, Journey? Journey? You right? You okay? Okay. And then you know there's 2 kind of points, free throws and field goals. You add those together. Any questions on the top one? Let's look at the next one. Example 2. The diameter of the earth is let me back up here a minute. This is all the way to the top. Students have not asked questions. Okay. Diameter of the earth is 828 kilometers, less than twice the diameter of Mars. If Earth has a diameter of 12,756 kilometers, what is the diameter of Mars? First of all, what is a diameter? It's not the circumference if it's diameter.
The radius. No, The other is
the
Sounds like
died that no.
it is a line that goes through the center. It's a line that goes. It's a line segment that goes through the center of the Earth sphere, as you would say. Okay, so that's my diameter. The words are: let the diameter of the Earth is your equals. Whenever you see is in some kind of a word problem, that is usually your equal sign. And the other one, 828 less than twice the diameter of Mars. What's twice? What number is that? 2 times. Twice the diameter of Mars. Well, we're going to let M be the diameter of Mars. That makes sense. Mars starts with the M. Let's let M be the diameter of Mars. So if I were to write this, the diameter of the Earth, and we know that amount. What is that amount again? What's the actual kilometers of that diameter? 12,756 is, that's your equals, okay, twice the diameter, but I want to show 828 less than that. So I'm going to say, if I want to show 828 less, that is minus 828. Does everybody see how I got that? And you're like, yeah, it's right down here, right below. Did you even see that? All right, so now we want to solve this equation. Jaslyn, are you with me? Are you sure? Let's put the phone away. I am trying to solve for M. If I'm trying to solve for M, I do not want to move M if I don't have to. So let's get rid of everything outside of M. What would that be? What would I be trying to get rid of? Yes? Come on. So if I want, okay.
So you have to do 12,756 plus 828 equals 2M.
Yes, we want to eliminate that subtracted 828 because we want to get the M term by itself. So add 828. Jonathan? 2M is equal to 6 and 8 is 14. 5 and 2 is 7, 1, 8, 15, 13, 1. Is that right? 13,584? That is 2 times the diameter of Mars. So, how do I get the diameter of just Mars? Divide by 2. 6,792 what? Yes, very good. I am a big stickler for trying to make sure you put a label on it. So please try to keep that in mind. Yeah, really. Any questions on that problem? Yeah. Kenyelle, come on. All right, let's go to the top of the next page. How can I get this smaller? All right, so how many of you are runners? Any runners in here? Okay. Have you ever run up a lot of stairs, like a fair amount of stairs? Have you ever walked up? Have you ever been to the Sailor and what's that in downtown? The Sailor something monument right in the middle of Indianapolis? And there are stairs all the way to the top. Huh? Yeah, there's memorials, there's lots of statues, but it's the something in Sailor's monument. I walked up those stairs, I thought I was going to die. And this was even like probably 10 years ago. Zion, don't say anything. Okay. So here it is. The Empire State Building. So much taller, right, Lorenzo? Run Up is a race in which athletes run up the building's 1,576 stairs. In 2003, Paul Craig set the record for the fastest time, running up an average of 165 stairs per minute. The function is C equals 1,576 minus 165 times M. That represents the number of steps he has left to climb after M number of minutes. Find the zero of the function, and interpret its meaning in the context of the solution or situation. So step 1, graph the function. We've already graphed it for you, or actually the book did. Estimate the zero, okay? Estimate the zero. Well, first of all, he has to go up 1,576 stairs. If I'm talking about the y-intercept, where would I find the y-intercept? And what would it be in this graph? What is it? No, that's not the y-intercept. Steps remaining, no. It's right here, and it is that 1,576. I just asked for the y-intercept. Okay, so that's where he's starting, 1,576. What's my x-intercept? Is it 9? Well, wow. I think it's right here. If this is 9, we have a scale of 1. 9.5. So that looks to be 9.5. I said that, says Jamie. Yeah, well, you also said lots of other things. So, all real numbers? When in doubt, that's going to be our answer if you don't know. Is it all real numbers, Miss Dee? That could be our little inside joke. All right, the graph appears to intersect at the axis at about 9.5. So everybody see that? That means that Paul Craig finished the race in about 9.5 minutes, or 9 minutes and how many seconds? 30 seconds. Yes, because 1 minute is 60 seconds. And so half of that, if you divide by 2, is 30 seconds. That's how we got that. Okay? So now we're going to solve this algebraically. Because when you look at a graph, how accurate is it to look at a graph? You get an idea, right? But you don't necessarily get the exact answer. What if we solve for it algebraically, though? Do you think it's going to be closer to a right answer? Possibly. Let's check it out. Using this equation, substitute 0 in for C. So if C is 0, that means he has 0 steps left. So let's put a 0 in here in place of C, equals 1,576 minus 165 times M. So he's averaging, running up 165 steps per minute. I want to try to solve for M. I don't want to move that M term. So what am I going to have to do first? I need to add it? Is that what you said? Yes, we need to subtract. I need to move that full amount of the stairs that we have. And I'll move it by subtracting. Minus 1,576. Those cancel out. And I get negative 1,000. Whoops. So newbie. I can't find the eraser on here because everything is so large. Never mind. You wouldn't understand. Negative 1,576 is equal to negative 165 times M. I am solving for M. Okay, share the wealth, Zion. Hang on.
Will it be?
Hang on, don't say it. Kimberly, what do I need to do next here? Huh? I'm trying to solve for M. We're right here. What do I need to do next? Here's my M. What's happening between negative 165 and M? It is being multiplied, so I will divide, yes, by negative 165. And this is where it's really nice if you have a calculator. You get M is equal to 9.55. And what is that? 9.55 what? Minutes. Okay, so the solution is about 9.55 minutes. So this Paul Craig completed the Empire State Building run-up in about 9.55 minutes, or that is 9 minutes. And is that 9 minutes and 55 seconds? How did you get that to be 33? Isn't 0.55? Isn't that 55 seconds? No. It is 33. So how do we find that though? You take the answer that you have, 0.55, and that is part of a minute, right? You also know that in 1 minute, there are 60 seconds. This is what we call an equivalent ratio. 60 minutes or 60 seconds and 1 minute are the same, but they're in different units. So if I put this over 1, multiply top times top, bottom times bottom, you're going to get 33. Your minutes and minutes here will cancel out, and you're left with 33 seconds. So it is 9 minutes and 33 seconds. So, given the choice, if you have to show a graph or do some algebra, to get the most accurate answer, use algebra. If you want it to be a nice visual, then probably showing a graph, okay? But you still want the actual best answer. Any questions about this information? Okay, so that's all the notes we're doing for today. Let me remind you, hang on. Homework number 1 is due on Tuesday. Okay, tomorrow we are going to be graphing inequalities, which you've done before. So you can already do most of homework number 1. That means as this is still class time for math, take your homework out, okay? In addition, we also have these weekly Canvas activities. Tomorrow is the last day to get the one done for the 17th. And the one for the 25th should be done for tomorrow also. Okay? Those are completion points. You should be able to do those. All right? Now, I think everyone in here has taken the test now. Sherlyn, you just turned yours in, right? So I will pass back the test, but I need to collect them. Do not put them away. Do not take them with you. Do not pass